to need your textbook. I'll be passing out the assignment in class. Okie doke. We are multiplying and dividing rational expressions today. That is the plan. Now, actually, some of the problems will ask you to multiply or divide. Other problems, you're just kind of simplifying. So I just put simplify each expression for the directions here. That's just kind of in general. And again, like I said, some of them will have to multiply, some of them divide. We'll just see what they give us. Okie dokie. Here is example 1. Directions say to simplify. Now we've got a 4y on top times the quantity y minus 3 times y plus 4 all over. There is a y times y squared minus y minus 6. Now, this is more just a simplifying type of problem. We're going to kind of build up to the problems that ask us to multiply or divide. This is basically just one rational expression that we have to simplify. Now, I put a couple steps up here. Since this is our first example, I'll put those steps up, and we're basically going to follow those steps on all of them today. But step 1 is to factor the top and bottom. When I first taught you guys how to factor, I said over and over, this is so important. You're going to learn it right now, but you're going to use it a whole bunch later on, not just this year, but next year. If you take pre-calc, even in calculus, we factor every now and then. So factor the top and bottom. Now, I will say that sometimes you can do a lot of factoring. Other times you may not have a whole lot to do. If you look on top here, 4y times y minus 3 times y plus 4, I actually don't think there's any factoring to do. It kind of looks like it's already been factored with those 2 parentheses there. So I'm going to leave the top part the way it is, because once again, it's basically already been factored. But now we have to look at the bottom. And I know it's been a while since we learned how to factor, but remember with the trinomials, forget this y out front for just a minute. Anytime you have a trinomial with like a y squared, y and a constant, or maybe it's x, or maybe it's something else. But if there was no coefficient in front of the y squared, other than 1, we called that nice factoring. That was my term, nice factoring. So to get this part factored on bottom, we are basically going to leave this little y in front. You can't do a whole lot with that y yet, but let's go ahead and set up a couple parentheses to do the nice factoring in the back. All right, to get a y squared, you're going to have to take y times y. If you forgot the shortcut for signs, here it is. If the sign on the right is a minus, these signs are going to be different. And the reason I call it nice factoring, or one of the reasons I call it nice, is because you're going to be able to do both of these things. The 2 numbers you pick need to multiply to negative 6 and add to negative 1. You don't see the 1, but technically that's negative 1. So what numbers do I need? 3 and 2. Which one goes with the minus? 3. So a plus 2, a minus 3. We've done step 1, factor the top and bottom. It turned out on this problem, we could really only factor the bottom. Now, the second step, and kind of the final step really, is to eliminate common factors. Eliminate common factors. Okie doke. Now, basically, eliminate means we're going to cross some stuff out or drop some stuff out. And common factors just means the stuff that's the same. So if you look on the top and the bottom, the first thing I notice is the top has a y minus 3. The bottom has a y minus 3. Those are common factors. We're going to drop those out. Now, if you're concerned that they weren't right on top of each other, it really doesn't matter. Multiplication is commutative. I could have put right here y minus 3 times y plus 2, and then it would be up and down, but it doesn't matter. As long as you've got the same thing on top and bottom, that's a common factor. Now, there's no other parentheses that we can drop out. That's a y plus 4, that's a y plus 2. Those will have to stay the way they are. But I do notice the stuff out front has something in common. A little y right there and another little y right here. I may actually go ahead and cross those out also. Now, basically, once you cross out everything that you can, you're just going to put it all back together. So if you look on top, you still have a 4 in front, and you still have a y plus 4, so that's what the top part looks like. On bottom, it's just a y plus 2. I probably don't have to put parentheses around the y plus 2 since there's nothing in front of it anymore. So you can drop those off if you want, that's perfectly fine, but that's all you can do with this problem. Sometimes in these lessons, we get a little cross out happy and we try to cross out stuff that we shouldn't. That y and that y can't cross out because it's a part of a factor and it's not the same. Also, you don't really have to distribute. I'm trying to throw out all kinds of things that you might be thinking about. You don't have to distribute. You don't have to have those parentheses on bottom. And definitely don't try to cross out anything else. Okay, so factor everywhere that you can. Eliminate the common factors. Let's keep trying a few more here to see how this goes. Number 2. Okie doke. Example 2. X plus 4 all over x squared minus 16. Again, we haven't really got to the multiplication or division part yet. This is just one rational expression that we're trying to simplify. Okay, I'm looking at the top, I'm looking at the bottom, I'm trying to see if there's anything I can factor. Now the top, nothing you can do to factor that. It's just going to stay x plus 4 for right now. On bottom though, anybody recognize this type of factoring? Yes?
Difference is squared.
Very good. It's not yucky. It's not nice. The actual name for this is a difference of squares. We're going to run into that a little bit in this section. So I'm leaving the x plus 4 on top. And if you forgot how to do a difference of squares, let me remind you. First of all, the term that you're going to put first in your parentheses, it comes from whatever you have to square to get the first term over here. What do we have to square to get x squared? X. And then what do we square to get 16? 4. Make one of those a plus, the other one a minus. That's always how you do a difference of squares. So I factored everywhere I could. Now I'm going to eliminate common factors. Okie doke. So I've got an x plus 4 on top, x plus 4 on bottom. It looks like on top that everything is gone. So you're maybe tempted to put a 0 there. But technically what's happening here, when you eliminate those, it's actually like you're dividing both of those by x plus 4. What do you get when you divide something by itself? 1. So yeah, you're going to have to stick a 1 on top there, and then just the x minus 4 on bottom. You don't have to have those parentheses on bottom anymore if you don't want. I kind of like to keep them there so you're not tempted to cross out something that you shouldn't. If you see the parentheses, you kind of know that all of that has to stay together. Okie doke. Any questions so far? Moving along then. Number 3, getting into some good ones here. Number 3 says 2y times y minus 3 times y squared plus y minus 20, oh boy, all over a 6y squared times y squared minus 7y plus 12. Okie doke. Got a little bit more happening on this one. What you really want to do first is pick out the stuff that can be factored. This 2y, I mean, I guess it's already kind of like a GCF maybe that they pulled out front. So I can't factor any of that anymore, but I can factor this part. This looks like it's nice factoring back here. So leaving the 2y times y minus 3, let's keep going and factor this part after it. So y times y is going to give you the y squared. Signs will be different. And again, this is nice factoring. I'm not sure if we'll see any yucky factoring today. I hope not, but you never know. With nice factoring, you're going to pick two numbers that multiply back here to the negative 20 and add to the positive 1. So 5 and 4, and I believe you'll want the 5 with the plus. Okie dokie, and I'm looking on the bottom now. 6y squared is already kind of pulled out front there, so I'll probably leave the 6y squared, but after that, this can be factored too. This is more nice factoring. Actually, on this one though, both signs are going to be negative. Now, two negative numbers that multiply to 12 and add to negative 7. What would those be? Yeah, 4 and 3. 3 and 4, the order on that would not matter since the signs are the same. Okie doke. Now it's time to eliminate our common factors. And remember, it's okay if they're not lined up. You just have to have one on top, one on bottom. Looky there. Y minus 3, y minus 3. Y minus 4, y minus 4. So that was nice. Now I'm looking at the two terms in front. You can do a little bit more with these. Now, there's different ways that you could think about this, but I want to just think of those numbers first. 2 and 6. What's the biggest number you could divide 2 and 6 by? 2. So that'll just kind of drop out there, and that will become a 3. Now, with the y's, I guess I could kind of word this the same way. What's the biggest y that you could divide both of those by? Just y, yeah. So y divided by y is just 1. That's not going to matter since I have something else on top. Y squared divided by y. I'm just going to scribble out the square there. So it's still y. It looks like on top, all we have is a y plus 5. You can leave the parentheses if you want. On bottom, we have a 3y. Now again, don't get cross out happy and start crossing out things you shouldn't cross out. For example, if you don't put the parentheses around the y plus 5, you might be tempted to cross out the y's, but you would not be able to do that. If you did that, you'd have to do something back here with the 5 also. So that's how we would leave it then for number 3. Okie doke. Any questions about that one? All right, I keep getting ahead of myself here, just kind of going off there. All right, number 4, ready to go. X squared minus 5x minus 24, and we are dividing that by 40 plus 3x minus x squared. Interesting. Now I'm looking on the top here, and this looks like it's nice factoring. The signs are going to be different though, so let's be careful about how we order this. We need one of them to be a plus, one of them to be a minus. What are two numbers that multiply to negative 24 and add the negative 5? I'm thinking an 8 and a 3, but the 8 needs to be negative, the 3 needs to be positive. If you mess up that order, it could really mess up the rest of the problem, because then you may not get as many common factors as you should. Now the bottom is freaking me out a little bit because it's in a different order than I'm used to. We should really have the x squared term first, the constant last. What I want to do on bottom is rearrange that order. Now the part that kind of stinks is right here. When I move this to the front, it's actually a negative x squared plus 3x plus 40. You can factor with a negative if you want. I don't really like to do it that way, so I'm going to leave the top part the way it is for a minute. And instead of trying to factor with a negative x squared, another option is to basically factor out a negative And let's think about that for a minute. If you take all three of these terms and basically divide them by -1, that would be a positive x squared, negative 3x, and then a negative 40. I'm going to do it like this. And again, the top part is just kind of hanging out for a little bit while we work on the bottom. If you just factor out a -1, you can keep it out front while you go back to the nice factoring. If you don't do it this way, this would almost be like yucky factoring a little bit because of the negative. So now, different signs, two numbers that multiply to -40 and add to 3. Anybody know what that is? Yeah, 5 and 8. The 5 needs to be with the plus. Now we're looking good. X minus 8 will drop out. And as far as how to write this, you can leave it as x plus 3 over -1 times x plus 5 if you want. I kind of moved that negative out front just so I didn't have a negative on bottom. But again, I wouldn't count it wrong if you just kind of wrote it like that. That would be fine also. But we don't usually like to leave a negative on the bottom. Okie doke. Factor everything. Eliminate the common factors. Just a little bit weird there with the order on bottom. Any questions about number 4? Well, hang with me here. We haven't really got to the multiplication or division yet. I'm going to do one more like this where we're just kind of simplifying, and then I think 6 and 7 will be a little different. Those will be our last 2 problems. Okie doke. Top part. X cubed minus 6x squared all over x squared minus 10x plus 24. The bottom is looking great. I think this will be nice factoring on bottom. The top part though, I see the minus, but it's definitely not a difference of squares. Anybody know what we could maybe do on top? It was actually, go ahead. Very good. It's actually our first rule of factoring. We haven't really had to use it yet today, but these two terms have an x squared in common. That is our Gcf rule, first rule of factoring. If there's a Gcf, pull that out front. Now that would leave you with x squared times x minus 6. Okie dokie. So let's go ahead to the bottom here. Both signs are going to be negative. And 2 negative numbers that multiply to 24 add to -10. You're going to do either a 6 and a 4 or a 4 and a 6. Order there really doesn't matter. And this is looking good. Common factor. You know, typically you always get at least one pair of something to cross out. Some problems you get a lot to cross out. Other problems maybe not a whole lot. But for this one, we'll just leave the x squared on top and then x minus 4 on bottom. Can't do anything else with that. Okie doke. A lot of factoring today. Now, I'm not really going to change the directions for the last 2. We are still technically just kind of simplifying, but more importantly, for number 6, if you look in the middle of those fractions, we're actually multiplying. We're taking k minus 3 over k plus 1, multiplying it by 4k squared minus 4 all over k squared minus 4k plus 3. So there's two rational expressions. We are multiplying them together. Now, basically, we're going to start this out the same way. We're going to look up here and see if there's anything we can factor. Now, the first fraction, I don't think you can do anything on top or bottom for this fraction, but if you look over here at the second fraction, actually, I think you've got some stuff to do on top and bottom. So, I already have those circled. What do you know? I'm going to leave the first fraction the way it was. Now, let's not forget the first rule of factoring. We hadn't had to use it until that last problem. If you look on top here, these two terms have a 4 in common. So actually, we need to pull that 4 out front. Now, I'm going to give away a little bit about the next step. This right here is now, or actually it kind of was over there, but we need to do that GCF first if we can. Now you've got a difference of squares that we'll probably have to factor even further. Now I'll come back to that in a minute. Let me go ahead and see what I get down here. Both signs are negative, and two negative numbers that multiply to positive 3 but add to negative 4. You can do a 3 first, then a 1, or a 1 first, and then a 3. But I'm not done factoring yet. I'm going to recopy this first fraction. But like I mentioned, k squared minus 1 is a difference of squares. Let's keep the 4 in front, and then what you square to get k squared is k. What you square to get 1 is 1. Make one of those a plus, one of those a minus. The bummer about these problems is that you have a lot of rewriting to do in each step. I'm going to go ahead and rewrite what we have on bottom there. And now I'll start to cross stuff out. Here's some good news though. Instead of just looking on top and bottom to find those common factors, when you have two fractions like this, I think I kind of put this maybe as a step, maybe not, but you can actually cross out common factors on a diagonal. So like the k minus 3, k minus 3, k plus 1, k plus 1. You can cross out diagonally or up and down, or maybe you have both of those. We actually do here. We crossed out a bunch of stuff diagonally, but we also have k minus 1 over k minus 1. So those get crossed out as well. So the only poor little thing here that didn't get crossed out was 4. Now, this doesn't really apply to this problem, but do you know what the answer would be if it looked like everything crossed out, like if there was no 4 there? It would be 1. Technically, remember, when you cross something out, you're taking a term or a factor and you're dividing by itself, which will give you 1. This, though, still had a 4. Okie doke. just some more stuff to look for if you've got multiplication. Now, the last problem today is division. You really got to look at the sign in the middle so you know what you're supposed to do. We are taking a squared minus b squared all over 3a squared minus 6a plus 3, and we're dividing that by 4a plus 4b all over a squared minus 1. Now, question, we're dividing fractions here. Do you remember our cute little saying for dividing fractions? There's like 3 parts to it. We may or may not have talked about this yet, but we do want to remember when we divide fractions, we want to keep, change, and flip. I actually like to do this before I factor because I'm afraid after I factor I'll be so confused that I'll forget to go back and do this. So keep, change, flip. Keep the first fraction. Again, there's a lot of rewriting with this stuff, but keep that, change it from division to multiplication, and then flip the second fraction. So you always want to change your division problems into multiplication problems. Keep, change, and flip. Now I haven't factored yet, so that is the next step. Actually, this part on top here is a difference of squares. It seems like it shows up quite a bit. Kind of weird because there's 2 different variables, but what you square to get a squared would be a. What you square to get b squared would be b. And then just make one of them a plus, one of them a minus. Okie doke. Anybody know what I should do first on the bottom right here? Yeah, pull out a 3. So that's going to leave you with a squared minus 2a plus 1. Unfortunately, we're going to have to factor that one more time here in just a minute. I'll come back to that before too long. Now, I'm looking at the second fraction, and there's another difference of squares on top. You're going to need a plus 1, a minus 1. And for the bottom of that second fraction, I think all you can do is pull out a 4. So 4 times a plus b. Okie doke. Oh, darn. I'm going to rewrite the top part here and factor what's on bottom a little bit further. If you think about your nice factoring, you're going to leave the 3 in front. Both signs are going to be negative, and 2 negative numbers that multiply to 1 and add to negative 2, that would be a negative 1 and a negative 1. Okay, at this point, I've already factored everything I can in the second fraction, so I'm just recopying that so I can see it all together. And just like number 6, you can cross things out diagonally or up and down. There's more options when you are multiplying and dividing. So here goes nothing. I've got a plus b, so that's good. Also, I have an a minus 1, a minus 1. I realize there's another a minus 1 down here, but you can only cross out one at a time. So that'll actually have to stay on bottom. Is there anything else that I could cross out? No. So that's okay. What we'll do is, on top, just put the a minus b times a plus 1. You don't have to FOIL that or go any further with that. You can just leave those the way they are. Now I do want to point out on bottom, there's a 3 right here times a 4 right there. 3 times 4, let's go ahead and make that a 12, but then you can just put the a minus 1 right after that. A little bit more to do there on number 7. Questions about that? Leave that up there if you still need